Mada Climate Services Center. Then the next presenter, when he is done, the next presenter is going to be Dr. Tamoka Makazere. I think most of us know him. He once presented at our last year at our workshop on seasonal weather forecast. He is a regional scientist for Climate Hazard Center at the University of California, supporting FuseNet. FuseNet is a family and early warning system network. He is also affiliate research scholar at the University of Botswana. Before I can give a floor to them, I would like our CEO, I'm not alone, my CEO is also online here, Mr. Ishmael Sunga, to give us opening remarks. Thank you very much.
Thanks, Professor Sang, and good morning to everyone online. As indicated already, my name is Ishmael Sunga. I am heading the Southern African Confederation of Agricultural Unions. First of all, let me welcome you all from wherever you are. I see members joining from Madagascar and elsewhere. And also welcome specifically the presenters from the SADC Climate Services Center, as well as from FuseNet. This is part of our ongoing collaboration with SADC structures in terms of informing and educating our members to do the practice of agriculture as effectively as possible. We all know the importance of weather. I shall not go into it as organizations representing farmers in the region. But other than to say that weather is perhaps the only variable that is uncontrollable. So it is essentially farmers are at the mercy of the weather. They can't control it. They can't engineer it. Other inputs that are required to make agriculture a success, I think they have some control. They have some control over them. So that underscores the importance of climate and weather. And also to say that weather is not only about crops and livestock, it is also about people. It's about many other things. And we're excited today to get, as the title says, unpacking, just to get to understand what the seasonal forecast is going to be like, at least for now. It will be updated as we go along, I'm sure. Mr. Sunshine Gameze shall talk to that. And also, secondly, as already indicated by my colleague, to get an understanding of the possible implications on agriculture in crops or livestock and its various aspects. I look forward to that presentation, and I shall be coming in once in a while just to get also a better understanding from where I sit, and also to ask questions that might need to be on behalf of myself as well as on behalf of others, so that we get a better understanding of where we are going. And also perhaps to make suggestions about how we can improve this kind of interactions between SADC and ourselves along the season, not only at the start of the season as we have done before. Perhaps track it as it gets on, because the agricultural season is not only about its start, it is also about its process up to the end, when things are now on the shelves or in the stomachs of the final consumer. With those few words, I'll hand back to you, Hlolisang, to take us through. And I hope we're going to have a very interesting conversation. Thanks, over to you.
Thank you. Thank you very much, Mr. Ishmael Sunga. Right now, I'll give the floor straight to our first presenter, Mr. Sunshine Duduzi Gameze. Can you share the screen with us? Thank you.
Good morning. Good morning, colleagues. Good morning, Hlolisang.
Good morning. Yes.
Yes, and good morning, Ishmael. Sorry for Friday, I call you Israel.
No, my brother is Israel, by the way, so it's not bad.
Yeah, I realize. No, thank you so much. Yeah, so may I have access question when oh no, it's okay. Now it's okay. Thanks, Clarissa. Let me then upload my presentation for the benefit of all of us. Let me play it first. Just give me less than a minute. Yeah, I want to put it on slide mode before I share. Okay. Okay. So, share again. So I'm talking to myself. I want to share in a slide mode. Yeah. It's okay. I hope you are able to see it.
Yes, yes, we can see it.
Thank you so much. Yeah. So my talk will just be presenting what was projected during the SACOF forum that took place in Zambia, excuse me, from 8 to 11 of September. As you know my name, and that I work for the SADC Climate Services Center. So as I indicated, the results will be mostly looking at what was presented during the SACOF forum that was in Zambia from 8 to 11. But before that, we had a climate expert meeting from the 1st to the 7th, where the forecast was generated. And those are the processes that we followed. But the one thing that I would like to probably maybe emphasize on, because I presume, in as much as I'm presenting the forecast at the same time, because it's called a webinar, I think at the same time is to also to unpack and also to assist in terms of understanding and interpretation of the forecast. So the forecast is going to be given in 4 categories. One is above normal, as you can see there. Where's my mouse? Let me get the pointer. Laser. Yeah, as you can see here, I hope you can see the laser. So we'll have 4 categories. We've got above normal, we've got normal to above, and we've got normal to below, and we've got below normal rainfall. And the focus is presented by zones. As you can see, we've got zones, and also we try to make sure that the focus is a moving 3 months forecast over the entire season from October to March. So you're going to have 4 maps that I'll be showing you. And then the most important thing, I think, for users of this forecast, the one thing that I would say, and which I'm happy that we've got Dr. Makadzira with us, is that the focus that we issue as a regional center, together with member states, is only relevant for regional scale. And 2 is that this forecast is not necessarily useful to the last mile, which means the farmer. There are so many intermediaries in between. And amongst the intermediaries is the National Meteorological and Hydrological Services, who now at national level have to downscale this forecast to a national level forecast. And even at national level, now you need intermediaries that will now interpret this forecast like Dr. Makadzira will do at regional level. We have to have intermediaries that will now distill this even further for the extension workers at local level, and then they now distill it even further for the farmers. So a farmer is not necessarily advised to use this forecast as it is from the regional level, but a farmer can look at it as a guidance, but must then go further to get a much refined forecast at national level and get guidance in terms of how to utilize this forecast in terms of what implications does it have and how best to plan for those specific implications, which Dr. Makadzira, I'm sure he will be talking to. So at regional level, that's the structure. Even at national level, it's supposed to follow a similar structure, that you must have the understanding of the implications of a forecast. And then in addition to that, we must then have the explanation of how then this forecast can affect the different farming communities and the different sectors within the country. Because there would be also zones within the country which will give different forecasts. Even if the forecast is the same, the response may not be the same because you've got different climatic conditions that prevail over certain parts of each country. So those nuances then become important when doing the national or specific local area planning for farmers to now utilize this product. All those things need to be considered. So if you take the regional product, it may not answer most of the questions that you may have as a farmer, but if you take the refined product as it goes further down, you as a farmer, you may gain a lot of benefit from that forecast rather than the one that I'm presenting. So this one is it's at SACAO level, which is more of a guidance, but then it needs further refining. So now I can move on to how, in terms of understanding the product. So the principle is the same, both at regional and national. We use the same understanding in terms of the outlook. So we'll look at what we call uncertainty. The uncertainty, I'll show you, we've got a schema that gives our forecast and specific percentages that we allocate to each. So that's where we try to capture the uncertainty of the forecast. But the most important thing that we're doing with this forecast is that we show you direction, the most likely direction. But it does not mean that's the only possible outcome that may result at the end. But we give you the highest percentage on the most likely condition. And then the others, they also have a possibility, but at a lower scale, at a lower percentage as compared to the one that will give you as the main direction of the forecast, as it were. So this is how we sort of like categorize the forecast. We take a long-term historical record, which we call climatology. I hope most of you have heard of that word, but climatology is just from climate. We've just put the logy, which is the study of climate. So, but otherwise, it's just the climate over a 30-year period. So as you can see with this graph, we started doing the historical record from 1981 to 2010. So we now plotted for each season the rainfall that was received over this period. But we plotted these rainfall amounts, which is seasonal. These are seasonal totals that were received for each of that season, whatever the season was, in this case, whether it's October, November, December, or it's December, January, February. We plotted this per each year to say, if we're assuming that this is December, January, February, so this will be the total of December, January, February of 1981, 82, like that. So, but we use the first year. If it's overlapping to the next year, we put the first year when we're plotting our time series. So in this case, so before we are now plotting on top of the historical statistics. So you can see here we've got a 33% and a 33%. This upper 33% is what we call 66%. So we split the 100% of the entire record. We split it using a ranking of all these records. We rank it and then we split it into 33%, 33%, 33%, because we divide 100 by 3. If you divide 100 by 3, you will get 33.3333 all the way. It will never end. It's to eternity. So we just round it up to 33%. So we slice the 100% into equal percentages. And then because of the equal percentages, you now see the middle one, which is the 33 to 66. This is 66. The middle one is what we call the normal. So the normal is not a 1 point, but it's a band. As you can see, this band in the middle, and the band that is above, which is blue, that's the above normal band. And the band that is reddish, whatever color you see, which is lower than the 33%, that's the band we call below normal band. So we've got below, normal, and above. But you see, when we present the forecast, we present it in 4 categories instead of 3 categories. That was a request from users that we split the normal, because the normal, most users, they said it didn't mean anything to them, because when now they try to interpret, you are saying normal will most likely be what everybody is expecting. To them, that's not a forecast, because they want to know will this rain be more than what is usually received, or will it be less than what is usually received? That's why then we've got 4 categories instead of 3 categories, because we split the normal into 2. So now we've got normal to above and normal to below, and then below and then above. That's how now we present the forecast. We add 2 more categories in the middle instead of just having 1 category. So I hope we understand how then the forecast is usually categorized using historical. So whatever value that we are going to forecast, it will have to fall within these 3 categories, as you see. But because we split now into 4, then we'll have either it's falling in the lower part of normal or in the upper part of normal, which then it means it's got a bias towards above or a bias towards below. That's what the normal to above stands for. So now, in terms of the presentation now of the different outlook. So we have this equal chance, which is the climatological probabilities. I hope most of you understand probabilities, which is, I just use another way to represent it, which is a chance. Chance being, if you have played the EPOP, I'm sure some of you know what pop is. If you've played dice, yes, either you crap or you pop. So if you play dice, you know that it has to fall somewhere, the dice. It has to give you either between 1 and 6 values. So how many times you get 6 or you get 1, it depends on the permutations of that. So then it goes now to mathematics and statistics to derive the probabilities and the percentages. So for us, we are using the same principle, but now using our observed rainfall. And then because we are not trying to observe, to forecast the future using the past, but we're using the past to learn, to teach a model. So that's where now things start changing. So we use the idea of probabilities to develop a model that will now be able to give us the indication of the future, but using specific known relationships that exist between what we want to know, what is going to happen in the future, and what has happened before, between the two. So now we call that a model. So most of the time, some of you probably are statisticians or financial forecasters or people dealing with futures in maize prices or whatever. You then use in statistics, you use what we call a regression model, which is a model that you need to train your past observations. You train the model using past observations so that when you make a change in the variable that you are using as an indicator for what is likely going to happen, you then use that, and then it will give you now. So now we are driving. We are using it as a driver. We call it drivers. In our language, we've got climate drivers. So we use those climate drivers to now give us the indication of how the future will look like, basing on the relationship that we've seen in the past. So that's where then we now start allocating from the 33%, we start allocating these percentages, because now we are using our understanding of what has happened before, and together with the relationship of what we're using as an indicator. So I'm sure most of you have heard of El Nino, La Nina, and all that kind of stuff. Those now is what we call indicators, which for us, in our language, we call them climate drivers. But in simple language, those are just indicators. They are not a forecast. They are just indicators by which you can then put them, plug them into a model, and then the model will now give you how it is likely going to behave in the future in terms of, if you've got El Nino, how will it affect your specific rainfall performance in a specific area? But it's based on that understanding that has occurred in the past, but now it's driven by a model which you can then investigate. How good is my model in simulating the future using past experiences that have occurred? So as you have seen, as you can see here, probabilistic forecast does not tell us whether the season will be above or below. It tells us what is the chance of above or below or normally, as you can see here. So I'll use this as an example to explain how then you can interpret the forecast. If we give you the forecast in the map, we'll plot only this one in the map. We'll not plot these ones. But you should know that these ones are also embedded in that forecast where we say above normal. So it means we have got a higher confidence on the above normal category of the three terciles, but we also have the next possible category in terms of the occurrence of the forecast is that we may most likely, if we don't achieve this one, there's a high chance we are likely going to achieve a normal forecast. And there's also a small chance that we may receive below normal rainfall. So you can see where we talk of uncertainty, this is where uncertainty comes in. We are sure this is the signal that we're getting in terms of the relationship that exists between the rainfall that we've seen in the past and the predictor, which means the indicator that we've used to relate with this rainfall. But in as much as that we have that relationship, we also have a possibility that we may not receive it. And if we don't receive this is highly likely going to be the next potential outlook that may occur. So which means if we don't achieve above normal, we are likely going to receive normal rainfall. But a very small chance that we may get below normal rainfall. Just like in chance and probabilities, as it were. If you are playing dice, like I gave as an example, you are playing, tossing a coin, you have got two possibilities, but the chances of how many heads you can receive, how many tails you can get, that's where now the uncertainty comes in. Now let's move on now to look at the whole suit of the same thing as it appears in the map. So we have now given colors for the different categories in our forecast. So we have got below normal, which we represent by brown, as you can see here on the outlook map. That's where we have got confidence in terms of our outlook, which is driven by the relationship that exists between the indicator, which I call a predictor in other language, and the predictant, which we call your expected outcome, be it rainfall, be it temperature, what you want, the element that you want to know. How will it be? Will it be below? Will it be above? Or will it be normal, or whatsoever the case may be? So this is now a representation of the forecast on the map. This is the SADC map. And then the next category is the normal to, which is what I said, we now chopped the normal category into. We've got normal to below and normal to above. So yellow represents the normal to below. So you can see that in the middle, we've got the highest percentage, which is 40% being put there, which is the normal category that we anticipate. But the next possible outcome, which is the direction now, is that these rains, we're expecting them to be normal, but they have got a possibility of being below normal. So they are normal rainfall expected, but they've got a possibility of being below normal. But there's that small chance that we may have, which is 25%, we might have above normal rainfall over the very same area that we are. So that one is a very small chance. And then we have got the normal to above, where we've got a small chance on the below, but a higher chance on normal, followed by normal to above. And then we've got above, where the highest percentage is put on the above normal, just as it were on the below normal, as you can see there. So this is what we give. So we are giving you in terms of the direction of the focus over that area. As I said earlier on, I said these forecasts are applicable to large areas. You can see we've got so many countries that are falling inside this yellow, and we've got about 3 falling in this brown. You've got a lot falling on this color cyan, and also covering that part of the continent, and also the island states, as you can see there. They are all covered in terms of the outlook that comes from the regional process. So as you can see on that yellow box, that the focus for below does not tell us that rainfall will be below normal, as I've just given you here. You can see that below is the highest percentage, but you also have normal and also have above, which those are the potential chances. It tells us that there is an increased chance of below normal rainfall. So that's how we should look at it and understand it, is that we've got a higher chance of that specific category. So the drivers, which is the indicators, as I said, the drivers that we track within the region, we track the ENSO. So the ENSO in full is called El Nino Southern Oscillation. Apologies in advance that we are used to using these acronyms, throwing them around. I would like to apologize to those who are connected to this. If there's need to extend it, I'll try to make it extend these acronyms for the benefit of usage of this presentation in future. I'll try and expand them for you. So the IOD is not iodine for salt, but it's Indian Ocean Dipole, and the SIOD it's in the south, but the same thing. It's an Indian dipole, but in the south of the Indian Ocean. And the TAS is the tropical Atlantic in the south. That's where our interest is. And then Benguela Nino it's a signal that is closer to Angola and Namibia along the coastal areas. That's where we measure the effect of the Benguela Nino. It's not the same as El Nino, but it takes the what you call the understanding. It's similar because it's a cyclic system that was identified over that part of the subcontinent. It got the name of the Benguela Nino because it's sitting there. So now, in terms of the different what drivers that we track, this is a global setup, as you can see. Most of you, I'm sure, have heard of El Nino. We are only interested in Nino 3.4, which is where there was a clear relationship that exists for us in the sub-region between that part of the world and us here in Southern Africa. So, and then the Benguela Nino, as I said, is this one here, which is taking a little bit of the basin of the TAS, which is a bigger basin. The one that is green takes a bigger slot, which includes also the SAT, the Southern Atlantic, tropical Atlantic zone. And then we have got a SWIO region, which is the one that usually gives us an indication mostly of what is likely going to happen are closer to the Mozambican channel, which is the one that usually gets a lot of, affects us most. If you've got warm waters here, there's a lot of activity that usually affects a majority of parts of the southern part of the region. And then you've got the SIOD, which is what I was talking about. This one gives us indication in terms of tropical cyclone activity over the region, because you've got a dipole effect where we've got measurements of the west and the measurement of the east. So if you've got warm waters over here and also going all the way, especially if we have them here, it means the tropical cyclones will start here. But if you have it here, if it's warmer this side, they'll start from there. And then depending on the pressure systems, it will then tell in terms of the trajectory. Most of the time, tropical cyclones usually start, either they start here. If the high pressure systems are not high, then they just go down and they disappear. They just go like this and go. But if the high pressure is higher here, the 1000 pressure line, it's high, then they find themselves going lateral, like we saw with Fred. Fred started from here, and it went all the way to Mozambican Channel, hit Madagascar. Mozambican Channel went to Zimbabwe, came back, and spin around here, and before it went. It spent a lot of time. It went back to Malawi and came down and went away. So that depends on the surface water, the sea surface water temperatures that we use these different indicators to measure, but you combine with other, as I've indicated, with the pressure, surface pressure and also upper pressure. We use all of those to detect the potential situation of that tropical system. Right now, we've got one that has started around here, and it's closer to Madagascar now, and it's likely the trajectories that it may hit Madagascar, go to Mozambique, hit some part of Mozambique, and then comes back to the channel, and most likely be taken by subtropical systems, and it disappears, as it's usually the case with most tropical systems. So currently, in terms of the different indicators, we can see the SAT is neutral. As you can see there, it was positive, and then it went down, and then it's projected. These are the different forecasts from different models. So you can see one model is saying it's going to be positive, one model is saying to be very negative. So, but you look at the majority of the models, they are saying it's likely going to be in the neutral phase. So that for us gives us an indication on how to now interpret the likelihood of its effect on the next coming season. This one is for the Benguela Nino. As you can see, it's saying it was now at a negative level, but it's projected to come back and be neutral. So together with this, we don't expect a specific effect that will influence the climate over the coming 6 months. And then this is the Suyo region, which is what I was talking about. This one is projected to remain at a positive level. It was positive, it was coming down, and then it stayed. So it's going to be above the threshold of a positive Suyo, Southwest Indian Ocean indicator. That one will stay there. And then if you look at the SIOD, which is what I was talking about earlier on, that if it's positive, it is anticipated that it will influence tropical cyclone season. It will influence the tropical cyclone season activity. So in this case, it's anticipated to increase the tropical cyclone season because we are expecting this area here to consist of warm waters as per the forecast that is given. But currently, looking at this, it was at negative level. It was very cold. But the forecast is saying it's going to be warmer. We should anticipate for warmer waters there. And then for the IOD, which is one of the major regional drivers, is that we anticipate, because it's going to be negative, it's not going to be positive, as you can see, it's in the negative and it's rising to neutral. So while it is still in the negative, the anticipation is that this area will be colder and this area will be warmer. So we'll have relatively negative, a negative influence in terms of rainfall over the northeast part of the region, which means Tanzania and including East Africa rainfall situation. So the anticipations that combined with the El Nino situation, this is anticipated to bring forth drought conditions over that part of the region, provided everything stays the same as indicated by the different models. So now let's look at the actual situation for ENSO, which is one of the global drivers, is that we anticipate that for the Nino 3.4 region, which is the region of interest to us, you can see that the anticipation is that we should have relatively negative, but in the neutral phase, according to the forecast. Right now, in terms of the July observations, we were at neutral phase, but the anticipation is that it should go down to negative. We're expected to achieve negative values in October and November, and then December, it's a touch and go situation. It may be starting now to go up. So these are different from different centers. This one is from the WMO lead center, which is combining quite a number of models. This is just the Australian model. It's one model, and this is the UK model, which you will find some of them here included in this one for WMO. So this one is the Japanese model that you see there. But this is the one that we usually look at together with the European one, which is a combined, it's an ensemble model outlook. So all of them, they give a similar indication that we may touch El Nino conditions. But for the Australian, they have got their threshold is usually higher. It's at negative 0.8, but the global standard is that it should be negative 0.5 for La Nina to be confirmed that it's a La Nina condition. As you can see here from the WMO, we have got negative 0.5, which some models are touching that, and the mean outlook is also giving us that we may achieve La Nina for 2 months, which is October and November. Now, if you look at the IOD, this is from the Japanese model, it's giving us that we also have negative. And even the Australian is telling us that we are going to have negative IOD. And also the UK Met model is saying the same thing. And also the Copernicus combined model output is also giving us a similar situation that we should anticipate negative IOD, which is not good for northeastern part of the sub-region, because that now combined with the negative ENSO, it means we're likely going to have a likelihood of drought over the areas of Tanzania, northern Mozambique, some parts of Zambia, according to the understanding that we've had over time. But in terms of the areas as it were, this is the forecast for October, November, December, January, February, combined over the entire global oceans. You can see that next to us here, we've got warmer waters, which is good, but you see the area that I was talking about. We have got normal and cooler waters closer to Tanzania, which is one of the member states of the SADC region, and Comoros and but warmer over some parts of Seychelles, as you can see there. So the cooler ocean waters will not give good advection in terms of moisture moving into the subcontinent, as it were. You can see the same thing in Australia. Outlook, their access model, it's also showing that the projected sea surface temperatures from September to November is that it will be warmer this side and cooler this side, but we have that slightly warmer. And this is the European combined multimodal ensemble. You can see we've got slightly warmer temperatures in the southern part of the region and normal temperatures that are anticipated over the northeastern parts and also the Benguela-Nino area. And so these are indicators that we're using to track to see what type of influence is likely going to happen over the subregion. Now, they also then issue their own forecast. In this case, you've got the global outlook for global producing centers, which is the approved centers by WMO. So this is the WMO output from the WMO lead center for October, November, December. You can see that bulk of the south, there isn't a clear signal except for some wet conditions over coastal areas of Namibia and wet conditions over southern Mozambique, southern Zimbabwe, in northeastern South Africa and maybe some parts of Eswatini. And there's a dry signal over the area of Cape Town, but Madagascar is relatively wet. Mauritius, there isn't much of a signal, but dry over Comoros and over Seychelles, very dry. And then that signal which I was talking about over Tanzania, you can see that dryness, southern DRC and most of Angola. The same is also indicated over the Angola area by the Copernicus C3S program, and then also over Tanzania, not as heavy as you could see from this side, but there is that signal. But the wet signal that we see here is over Madagascar and the eastern parts. Because of the warmer CO region, we anticipate that it will have a positive influence in terms of the rainfall over that part. And then from us here at the center, we also have the multimodal ensemble that we issue. We combine the ECMF and the American CFS V2 and the CCSM4 and the GeoSS2 2S that we put into our multimodal ensemble, which is calibrated for us in the region. So you can see because it's high resolution, it's picking some of these dry areas for the same period over Madagascar and some dry areas over the same areas that these models are giving us a wetter signal. But if you look at the UK model, which they can't share with us this time around, you can see they indicate a very wet signal over most of the region, except for those areas of Tanzania and also areas of Angola. And then if you look at DJF, which is the December, January, February, or January, February, March, the DJF is very important for us as a region because it gives us the mid-season rainfall. That's like our summer season, the December, January, February. So you can see that there's wetness even from the WMO, almost in most of the areas in the south. And also with the UK model, you can see there's a lot of wet conditions that are expected to prevail over most of the southern part of the region, except for those northeastern, northwestern parts, which the dry signal, as you can see here, is anticipated to persist moving into the middle of the season. And then also you can look at if you look at the Copernicus, which is a European multimodal ensemble output, it's also persisting with the wetness over most of the southern parts of the region, but dry conditions over the northeast and the northwestern parts of the region. Even ours for the NDJ period at the time, because I'm presenting what we looked at when we were coming up with the forecast for the region, we were also seeing that there's an increased wet signal over this member states, over this region, as you can see there, and the dry conditions, but it was a mixed bag over Tanzania. It was not entirely dry in terms of the ensemble members that we consider. Now presenting the outlook for that was done by the member states together with the center, is that the agreement that was made is that for the region 3, as you can see there, it's going to be below normal, which is from South Africa all the way to southern Angola. that coastal area is expected to be relatively dry. As you have seen also on the sea surface temperatures, there wasn't really a warm or wet, there wasn't a cold or warm signal over the sea surface temperatures over that part of the region. It was relatively white here, as it were also here. But the bigger region, which is region 2, is anticipated to be relatively drier. Not dry, but relatively dry. If this one is expected to be drier, this is relatively dry. If you want to use simple language, this is relatively wet, even this one relatively wet, which is in agreement with the global models. And this is relatively wet, the central east of Madagascar, but bulk of Madagascar is anticipated to be relatively dry. Together, Mauritius and Seychelles, they are expected to be relatively dry during the OND. So on your right, this is the usual received rainfall historically over the entire SADC. So you can see most of the rains is usually at this time of the year. It's usually around Angola and DRC, much at the bulk of the rains, and also over Madagascar and this area here over South Africa, Eswatini, and Lesotho and southern Mozambique. So, but the bulk of the actual activity is usually in this part of the subcontinent. Now, if we move to November, December, January, which we call NDJ. So for NDJ, we can see that the focus now changes. The dry signal that was here is gone, but we still maintain the relatively drier, not necessarily dry. As you can see, it's connected from this side all the way, moving all to the Angola side. But we continue with the relatively wet signal over region 1 and over region 2, over region 4, and region 8 and region 6. But we introduce above normal rainfall on region 5 and region 7. And then we maintain the drier situation over southern Madagascar, Mauritius, and also Seychelles. Now, when we move to the middle of the season, we can see that most of region 1 now is having a relatively drier signal, excuse me, and region 3 still persists to be relatively drier, and region 6, which is most of Madagascar, especially the central parts of Madagascar. But there's region 2, which is covering bulk of the region, where we're expecting relatively wetter conditions in region 7, region 5, region 8, and region 9, expecting relatively drier conditions to persist over those parts of the region. And then when you move to the last season, in the 3 months moving seasons, we still maintain the wetter signal over these parts, but not the entire region that we saw over DGF, but we still have an anticipation of relatively increased precipitation over this. And with the runs that we do at the region, it is confirmed that bulk of this area will relatively remain wet. I can share that probably as an update to this, but for now, I'm just presenting the seasonal outlook as it was given in Zambia. So we can see region 1 will remain relatively drier now, and region 2 relatively wet, and region 3 wet, and then region 4, 5 will be relatively dry, and then 6, 7, 8 will continue to be relatively wet even in the next. So in summary, this is the situation, and these are the countries as it were, if you have to take just the first and the last 3 months. So the first 6 months is the October, November, December, and then the last 3 months is January, February, March of the outlook. And then you've got member states that are anticipated to fall within the below normal, and member states that are anticipated to fall under the normal to below, and then the normal to above. For this part, we don't have the above, so that's what we have. We've got those 3 categories. And then for the GFM, we've got member states that are expected to fall under the normal to below category, which is this yellow region. And then you've got normal to above, which is the cyan region, all of this. And then you've got above, which is the blue one that we see there. In principle, that's it in terms of rainfall. Now, when we look at the temperatures, at the time when we were releasing the outlook with member states, it was clear that for the first 3 months, this is what we will be expecting, that we'll have a warmer condition over most of these areas where you see a lot of red, but relatively warmer. But this is warmer, this is relatively warmer, not necessarily very warm as anticipated, as it will be for this parts of the region. But the bulk of the region will be relatively warm, will not be that hot. But most of Angola and DRC, because of the dry conditions, they're anticipating is that the temperatures will be relatively warmer, and also over Madagascar, based on the model ensemble that we took, it shows that we should anticipate relatively higher temperatures also northeastern Mozambique. That's the situation, as you can see also from this side, in terms of the actual degrees that are anticipated over the October, November, December period. Thank you very much, Jim.
Thank you very much, Mr. Gameze, for this concise, very informative presentation. I think I will take a few questions for 5 to maybe at most 10 minutes. And so if ever participants have got questions, you may raise your hand. I also want to have a question to you right now. My question would be, why is this focus for December farmers? I think it will be more important to have focused being done maybe in June, July, in order to prepare, to have more time for preparation for the upcoming agricultural season. Why can't we run them during then, June, July, and then we predict or for this coming summer? That's my question. I don't know if I don't see any hand. Do we have another hand here for people who are asking questions? If you have got a question, or you can write in the chat. I don't see anything in the chat as well. Hello?
Yes, I can hear you, Chair. Yeah,
Okay.
I see there's a hand now. Yes, go ahead.
There's a question from Betty.
Okay.
She's raising her hand.
Okay. You can move on, Betty.
Okay. Thank you very much for a very informative presentation. I must admit that some of this stuff is too technical for people like us who really but anyway, this is important for farmers. So my question, and I don't know if you mentioned it, I may have missed it. I wanted to understand whether the models that you use are also able to capture distribution, because many times, especially when you're looking at insurance schemes, when they just say you're going to have normal rainfall, they talk about the amount of rainfall that you're going to receive that season, irrespective of the distribution. So sometimes you could receive too little at the beginning of the season and then too much, but overall it averages out as normal. So I don't know if this is the situation that we're looking at here, or you're also able to look at distribution and able to tell whether that distribution is going to follow a normal pattern or it's going to be different from what it should be, which is almost average throughout the season.
Okay, point taken. I hope you get the question.
Yes, Chair. Go ahead. There's another one.
Or
So
another
Peter
question.
Yes.
Yes, we can. Yes. Hello, come move on, please.
Okay, thank you. It was a very, very nice presentation and very informative. My question is, how long or when do you often provide out these reports or these forecasts for us to easily access them? Because I see them as very important information that will assist us farmers in making various decisions. And in terms of accuracy, based on the practical point of view, how accurate is it? Yeah, those are my questions. Thank you.
I don't know if, Chair, you were able to hear. I had a problem. If Sospita can probably maybe repeat some of the questions I was not able to hear.
Can you hear me here?
Yeah,
Like
if you
he
can
says,
repeat, I think
we
you
couldn't
said
really hear you.
files.
Please mute yourself, Galsham. Let's allow Sospita can you come back again? We couldn't hear some of the questions. I don't know there's something that is echoing behind your voice.
Okay, can you hear me?
Yeah, now we can. Yeah.
Okay,
Perfect.
thank you. Well, so I had only two questions. One was, how often do this report is it published so that we can easily access it? Because I see it as a very important information for we farmers to use in terms of making various farming decisions. That's one. And the second one is, how accurate in terms of percentage the forecasts are. Those are two questions that I had. Thank you.
Thanks. Any question? I'm trying to check. I think for now, let's just let the presenter respond to the questions.
Thank you so much, Chair. Yes, and thank you very much for the interventions from the floor, Chair. I think I'll start with yours, where you were asking a very important question in terms of the timing of the outlooks. Why are they not done earlier instead of the time at which we release them? In fact, the biggest challenge that we have is the very same issue that I think Sospita has raised on his question in terms of accuracy. If we're to release, we can issue a forecast for some of the seasons as early as you indicated, but over time, it's something that needs a lot of research to see which indicators will be most useful. When I say most useful, I mean indicators that will show a good relationship and a good output that over time we can say we've got a good indicator that can give us a better outlook. So that's work for research, more research to be done. But as things are, we are hoping that with the advent of technology improving, we may now be able to ingest a lot of indicators, which we call them predictors, a lot of indicators, and try to do a lot of combinations to see, do we have indicators that can give us a very good, but currently the science, as it were, supports that we should issue our forecast around August, because before we were using the observed, we had very good predictability when we were using the July observed SSTs. Now we are using even forecasted SSTs to run, and we've got an improvement in terms of our tools that we're using. So there's more in terms of ability now to come up with the forecast. So I wouldn't say we cannot do it, but the answer to the question is that for now we're using the understanding and the knowledge that we have in terms of the predictors that we use as a region that give us a very good performance after the end of the season. Then I can move on maybe to Mepet. She was raising the issue around the distribution. I know for agriculture is very, very important. That's why we have come up with this moving 3 months outlooks. We used to just issue October, November, December, and January, February. So now we have put in the intra-season outlooks for November, December, January, and December, January, February. We're trying to bring forth. We started 2015 to introduce this. We're trying to bring forth the aspect of distribution, but that does not mean that there's no avenue for us to improve as a region, which goes back to the issue that I've just raised, the issue of research. We need more research to give us plausible approaches for us to be able to determine the distribution. A thought that had been raised by statisticians is that we may look into, instead of forecasting the amount of rainfall, we also focus the number of rainy days. So those are the possibilities in terms of trying to detect the distribution so that we can have a product that can assist farmers. We do have on our website, which I'll share the link on the chart. We do have some projections of other indicators that are very critical for, but it's model output. It's not necessarily a forecaster's forecast, but it's model output forecast, which is what you can find on our website. It does give the forecast of consecutive dry days within each of these 4 seasons, so you can see how many dry days are likely to happen and how many wet days are likely to happen. But it would be good to have a forecaster's output which talks into how many wet days are we expecting, even to monthly time scale. That would be most useful maybe to. Sorry, I don't know if you heard me. I was muted. Chair?
Yeah, yes, we
Were you-
heard you, but towards the end, last sentence, we couldn't.
Yes,
But-
yeah, I just saw that I was muted. Sorry for that. Yeah, so I've
All
just
right.
put it back. Yeah, so I was saying for that one, we need to invest more in terms of research but we do have products that can assist farmers, but they're online, but it's advisable that they should work with the Met services in terms of interpretation and understanding. And then, yes, in terms of the outlook, as I said, I'll share the website, the current website. We've got the new website, but I'll share the old one because the new one is not yet live. But I'll share the old one, which the URL will not change. So if you use it next time, even when the new one is up, it will just, you will see that it is different. But for now, I'll give you the old website, but the URL is the same. It will be the same. So the statement is there. Something we call a statement. I can also share it with the colleagues, with the organizers of the webinar. We've got a statement that comes from the SACOF. So that has got more details than the presentation I've just shared. And in terms of accuracy, we have introduced in our outlook, I think in the past 2 seasons now, we started, I think in SACOF 28 in Mozambique, we started introducing the hashing as it were. I can just probably maybe, I forgot to talk to it. Let me just share again, Chair, so that maybe members can probably get the benefit of the issue around yeah, I can use this one because it's clear. The issue around the accuracy. So this does not necessarily mean that it's accurate. You can see over here, let me put the pointer so it's easy to see. You can see we've added something that we call high confidence. It was requested by users that it was the same question asking in terms of how sure are we of this signal? So you can see that on this above signal, as you can see here, we've got areas where we are certainly sure that the signal that we're picking it's a signal with high confidence. But in the same, you can see we don't have high confidence over these areas of Eastern Cape, moving on to to Northern Cape, as it were, if I'm capturing it right over South Africa. Also these areas here, we've got a forecast, but we don't have high confidence as forecasters. Even here, you can see where there's no hashing, those are the areas where we don't have high confidence. But where there's hashing, we've got high confidence in terms of the outlook that we've shared. So in essence, we've got that belief that we've got a higher confidence, meaning that there's high accuracy in terms of the outlook as it were. But we also do what we call verification at the end of the season. We do verification of the forecast, and that gives us how far were we off and how far were we on. So unfortunately, I did not put it as part of this presentation because I was given the task to talk to the upcoming season forecast. But we do check how far off and how close it was to the expected, and how many hits did we have and how many misses did we have as it were in terms of the outlook check. I submit. You have another hand, I think, online.
Yes, Dr. Kupiwa Prince, can you ask your question?
Yes, it's Kuipa. Yeah, thank you, Chair, for the opportunity. The SACOF, it gives this single focus around September. And we understand that the shorter the time, the more accurate the data. Why do you only give one, or maybe do you give other shorter focus as we go into the season for more accuracy? And then also you have mentioned it yourself that it might not be very useful for the farmer because it's a wider geographical scale. At what level is it useful then? How is the farmer to benefit from SACOF in terms of planning their farming season and so on? Is it that this information is more relevant to the Met offices, and then they will downscale for specific regions in the country? So that is the second part of the question, to say, how is a farmer at least going to glean something from SACOF?
Thank you so much, Dr. Kuipa. Chair, I hope I can go on and probably respond.
Yes, and I think it's going to be the last question. Yeah, can you respond to
Thank
that
you.
so that we...
Thank you so much. Thank you so much, Chair. Yes. Yeah, in fact, yes, it's a very important observation and a very important question in as far as user engagement is concerned. Yes, in as much as I've said, the forecast is not that useful to a farmer. That is not to say it's useless to the farmer. Farmers are encouraged to participate in the SACOF process because there is a session which I'm sure Dr. Magadzera will talk into. There's a session where we have got user engagement. We call it user interface platform, a user engagement. So the thing is that this focused, in as much as it's a regional focused, but it's encompassing situations that are at member states level. And the forecasters that are involved in coming up with this forecast are from the National Met Services. So in as much as we're presenting it at the regional level, there's a high chance that most of the signal that you're seeing that is occurring even over specific member states and specific areas, there's a high probability that those are the signals that you will most likely see even when the member states are downscaling, because the expectation is that it should not be far off from what the member states will finally present as a refined forecast. But now, in terms of the distribution of that forecast within the country, you may find that at regional level, we've covered most of, for argument's sake, I can use Zimbabwe to say we've covered most of Zimbabwe with a yellow color. But when you go to the national forecast, you find that they've got some blue somewhere, but the yellow is still there, but they've got some blue in certain areas and some cyan and some brown colors within that very same. Some you find that they maintain the same colors throughout as it were from the regional. Something's muting me. Is the host muted you? It's not entirely off, but it's within that's why it's still relevant, but we just advise you to say, if you want to use it with guidance from the member states. Because if you take it as it is, you may find that there are certain local effects that may render the outlook at regional level not relevant for certain parts of your country where you want to use this focus as an interpretation, but use it as a guidance, not necessarily as the final output, but guidance for if there's nothing, because there are some instances where you find that some member states don't release their forecast. But if you have access to this one, then you can then utilize it to guide you in terms of decision making. But it's more relevant for regional time level, where SACAO together with you can then assist you to downscale it, to distill it further down, which is why we are here to guide you in terms of understanding the outlook and how best you can utilize it if there's a lack of any outlook that may be there from the member states. I submit, Chair.
Thank you very much, Mr. Gamez. I think now we need to move on to the second presentation on the implications on agriculture. So, Dr. Tamoka Magazine, please take the floor.
Okay, thank you very much, colleagues. It's a pleasure to be with you all this morning, and a good morning to you. Let me just switch on my camera for 2 seconds so that you can see me. If we meet in the street, we can greet each other. And while I'm doing that, I'm also trying to set up my screen. It looks like okay, I've seen it. Seems like the interface for Zoom has changed a little bit since the last time I used it. So I hope you can see my screen now. Please confirm. Let me move
Yes,
to one off
100%.
here. Wonderful. Thank you so much. So I'm going to switch off my camera now, and we'll proceed with the presentation. So my thanks to Mr. Gameze for sharing his presentation for the SACOF. It was really a very insightful time that we had with the SACOF team in Lusaka. And maybe I'll start off actually by sharing my thoughts on the last question that was shared, or that was asked by Dr. Kuipa. I think it's a very pertinent question. And I would add to say that, in addition to the points that were mentioned, I think another very useful aspect of SACOF, even for farmers to also participate in that platform and the discussions thereafter, is one on the regional aspect of weather systems. Weather systems, they are not contained within a specific country. And I think understanding what is expected even in neighboring countries, getting an idea of some of the weather systems or the climate systems that might actually affect even your downscaled forecast, I think is quite useful. I remember a few years ago, I was quite impressed when I think I was then still somewhat starting out in my agroclimatology career. And I heard a farmer, I think he was a Zimbabwean farmer, who was saying, no, the Botswana high, affects our climate in such a way that this and that. And I was thinking, actually, this guy knows, I'm supposed to be an agrometeorologist, but this farmer knows more about the weather systems than I do. And so I think the model for the story there for me was, the more we understand and we know about the different factors that affect our operations, I think the better position we are to make decisions. So SACOF is one of those aspects that really gives us that information. It provides us, an opportunity for discussion such as what we're having here. So overall, I would say that we will continue to discuss, continue to learn together, and to share ideas about how we can improve farming operations and food security in the SADC region. So this is my opening slide. Maybe I've spent a bit too much on that one, but I thought it was a good opportunity to discuss and really start the presentation. Mr. Gamez has already shared this presentation, or rather this slide. I won't go much into it. You've seen what is expected in terms of SACOF. And you forgive me if I belabor the point, and I think I'm going to go in a little bit and add somewhat to what Mr. Gameze was saying in terms of understanding the forecast. I was taken to this quote when I was preparing for this presentation. Give me 6 hours to chop down a tree, and I'll spend the first 4 sharpening the axe. And the lesson here being that, I think we can actually spend more time laying the foundation, having some sort of an improved understanding, so that, by the time we understand better how to interpret and use the forecast, including its strengths and limitations, then we can make more informed decisions. So I think Mr. Gamez has already addressed this, so I won't spend much on that. We've been told that, the dark blue colors is above normal. The cyan or light blue is normal, normal to above, normal to below, and below normal, right? And so again, just to emphasize what Mr. Gamez mentioned, When we're talking about above normal, we're saying that above normal rainfall is the most likely. And we're looking at 3 month totals. When we're saying normal to above normal, average total rainfall for that 3 month period is the most likely. Above average total rainfall is the second most likely. This is, remember, the sign. And then below average rainfall is least likely. But again, as Sunshine mentioned, even though it's the least likely, there's still a possibility for it. I'll share in a few slides why I'm referencing that. But I think the same logic follows for normal to below normal, the yellow colors, and for below normal, right? So even though it's the most likely for below normal, we still have a possibility of the other two. And so how do we take into that in our risk assessment? And that phrase in particular is key when we see how best we can apply the forecast. Right. So in terms of, let's take the above normal for example. What you said, it doesn't mean that average rainfall or below average is unlikely or have no chance of occurring, but it's a probability. And we need to evaluate this forecast with an opportunity or risk lens. But we also have to ask ourselves the question, what is the level of risk that we can get from a particular forecast? How likely is above average or below average? And what do we mean as well by above average or below average? So again, Mr. Kamedze shared this information on this, and I'm just going to share with you a tool that you can use for the next couple of days, at least to help understand what this means for your area. Right. And then there's also, I think this is also relating to the questions that were asked later in the session. What we have versus what we need. So those two don't always align, do they? What we have is the likelihood that total seasonal rainfall will fall within a particular range. But just having listened to farmers in the past, my colleagues on the call, I'm sure many of you want to know what weather patterns can we expect throughout the imminent rainfall season, the one that is about to begin and has already begun in some places. In particular, how long is the season? When is it going to start? When is it going to begin? What is the rainfall distribution? Dry spells, wet spells, maybe we might have some incessant rains and flooding, waterlogging like we had in the past season. What is the temperature regime? And how applicable are the anticipated weather conditions over the next few months for my planned agricultural operations? So we'll look at this a little bit in detail, but I think there are different levels of forecast that we can use, SACOF being just one of the tools, of the many tools in our toolbox. But in addition to the seasonal forecasts, we also have the medium range forecasts, which you can use for tactical decisions. And we also have the short term, maybe 1 to 7 day forecast, which we can use for operational decisions, while the seasonal forecast might be finding it more useful for the for the strategic decisions that you might want to make for the season. So and then we also asked the question earlier, what ranges are being forecast? So this is a tool that some of my colleagues have developed. We call it the Seasonal Monitoring Probability Generator tool. But what it does is, I think Mr. Kamedze showed a similar graphic whereby they took the rainfall for each season from over the last 30 to 40 years. And then, so this is a similar tool, and it outlines the amount of rainfall that we received for each of the past, actually between 91 and 2025 is what we have said, what I said this tool for when I ran this analysis. This is particularly for Zambezia and Mozambique, January. What this tool gives us is that it can show the lowest rainfall amount we received. That was, I think, 2005. What was the highest rainfall amount we received? I think that was in 2001. And what is the 33rd percentile? So that's basically the cutoff for below average rainfall and the cutoff for above average rainfall. So based on that, we can then tell that, if we're saying rainfall in Zambezia and Mozambique is going to be average to below average, right? By below average or below normal, based on historical records alone, we're expecting rainfall between 440 to 689 millimeters. In the normal category, we're expecting between 689 to 852 millimeters. In the above normal category, would expect between 850 to 1,159 millimeters of rainfall. And that's just based on the historical record, which gives us a more or less decent overview of what we can expect if the future is going to be something like the past, which we know it usually is. But as we know, I said usually, which means sometimes it deviates from that. And sometimes you might end up with the lowest rainfall on record or the highest rainfall on record. But this is basically a decent guide which allows us to do our planning. And so for this forecast, I think for Zambezia, from the region, from the SACCO forecast, we're given a forecast of normal to above normal rainfall, which means most likely our rainfall is likely to be in that range, between 689 to 852, the normal range. And then the second most likely outcome might be 852 to 1159, the above normal. Right. So this is some information that already we can start using if we know what effects these rainfall amounts can have on our various operations. Similarly, again, I took another area, which in this case is Nkai in Zimbabwe, and we can see that the rainfall amount is much lower. It's still a normal to above normal forecast, but you can see that now the most likely is between 260 to 415 millimeters, and the second most likely is 415 to 655. And if we compare that, so you can see that our second most likely range is even lower for Nkai in Zimbabwe, is even lower than our most likely, than our normal range in Zambezia, Mozambique. So each area we have to look at it in terms of its the context, in terms of its climatology, which is why another reason why it becomes very important to interact with our meteorological agencies at the national level. Right. And then, sorry for so many words on the slide, but I think it's an opportunity to discuss some of the issues. And the main aspect that we're looking at here is what is the impact of weather on planning our agricultural operations? Given that we have the forecast now, we're talking about what we want, what we have available to us versus what we need. And some of the questions that we need answered are, what is the likelihood that the seasonal weather patterns that are forecast this season will be sufficient to support my planned agricultural operations? And in this case, I gave an example of a farmer who is a hypothetical farmer who is planning to grow 20 hectares of variety X, maybe it's of millet, maybe it's a low-yielding variety, or maybe it's a high-yielding variety, and 40 hectares to a variety Y of soybean. And so we need to ask he wants to know, or she wants to know, will this be a successful agricultural operation in light not only of the forecast, but other ambient conditions. And given that this is what I was planning, maybe was planning this by June, July, as Dr. Kuipa was mentioning that, sometimes if it's a bit late, I forget the other colleagues also mentioned that when the forecast is late, sometimes it limits the use that the farmer can put to it. But you also now start to think, once you have the forecast, what changes, if any, should I make to my agricultural operation in view of the seasonal forecast and the area's characteristics, especially the agroecology? So will I need a more drought-tolerant crop? Should I take out crop insurance? Should I maybe service my irrigation facilities to make sure that supplemental irrigation is available? Should I need it? Should I reduce or increase my planted area, given that there's either a reduced or increased risk of drought? So a number of different aspects that, and of course, this season things like field drainage, would be of particular importance given the forecast for normal to above normal rainfall. Which means there is also an increased chance of high rainfall occurring sometime during the season. If you've got areas, your fields are prone to waterlogging, it might be a good time to clean out or maintain your field drainage. Maybe sometimes other options can be deep ripping, ridging, and so on. Or sometimes when you've got the drought, a drought which is forecast, sometimes a good opportunity to to reduce one's head, given from experience.
Hello? Dr. Tamuka?
For the specific forecast, but there is a need to interpret the forecast given the particularities of your specific area, right? So moving on, some other climate-related agricultural considerations include, so you have the forecast, which is before you, but you also have to decide, what are the other aspects of the area. It might be from climatology. By climatology, I mean your expected climate or characteristics of your area. So some areas, for example, even though you have an above normal rainfall, which is forecast, some areas will still be prone to dry spells, maybe ranging from 2 weeks to a month in most years for different durations. So that's something that has to be considered regardless of the forecast outcome. Or they might instead be the flood prone, perhaps because of the topography. It might be in a downstream area or close to close to a floodplain. And so, or even because of the soils, it might be prone to waterlogging. And so those are also considerations that need to be made when planning that. What is the current soil moisture conditions? So whether the soil moisture conditions are currently high or low, that might present a buffer for you in the event of dry spells, or it might also infer an increased risk for waterlogging, particularly if you have got a poor drainage soils. And the current state of grazing, especially for livestock farmers, is important, as well as the current state of climate-dependent energy resources. So in terms of the vegetation there, this is an insight into what we currently have. This is a map from October 6 to 15 showing a satellite-based vegetation index as a % of average. So what these satellites do is that they actually give an indication of the vegetation conditions, and then based on some calculations that are done, these are now shown as a % of average. So those brown areas, for example, in all those brown areas, we're seeing that the vegetation conditions are below average. We'll call it the NDVI, or Normalized Difference Vegetation Index. Some of you probably have heard of it before. So most of the regions are actually below average, except for this area in Lesotho, part of Eswatini, South Africa, into Botswana, where we're seeing some above average vegetation conditions in those areas. But considerations there include, which areas are grazing conditions above or below average due to past rainfall seasons. We've seen those. And then you have to consider also how long change in light of the forecast. Now, I always joke with colleagues because I work primarily in early warning for food security, and working at a regional scale, we need to kind of use these satellite images to get an idea of what's happening at many different locations. But for farmers like yourself, you already know the conditions that are there best just by observation, by eye, whether your pastures are poor, they are good, and so on. But in addition to your visual observation, some of these tools can also assist with a deeper understanding of the current conditions. And so, for example, some farmers, what they do is under this issue of precision agriculture, we have some of these satellite images that are available even up to 10-meter scale or even less than that, which then allow you to really zoom into your pastures, your different paddocks, and see in the different areas of that paddock, where is the vegetation actually, or the pasture in better or worse condition. It might be more difficult to see, especially if you have got quite a large farm or field size. And so these tools can also help you to really zoom in and identify which areas might need additional maintenance. But given that we've got these below average vegetation conditions in many areas, the forecast for above average rainfall, average and above average rainfall, is actually promising and might allow then one to fashion one's decisions or plan around how they might actually facilitate the recovery of their pastures. Another consideration that I mentioned was the issue of energy, electrical energy. And as we are aware, I think especially for farmers in Zambia and Zimbabwe, which rely to some extent or significantly rather on the Kariba, the Zambezi River Authority runs this daily monitoring tool, actually, which this line here, the blue line shows us the current level of the Kariba Dam. The minimum operating level is that line there, the dashed line. I think that's 475.5 probably. And so they are forecast a number of different scenarios of where the energy levels might go towards. This also allows for additional planning in terms of, especially if your farming operations are heavily reliant on energy availability, electrical energy. This is also some insights that might be useful. Mr. Gameze also mentioned the issue of temperature. I think he gave temperature forecast for October, November, December. And perhaps I can supplement to this by looking a little bit beyond, I think, so looking at some of the global forecasts, which mentioned the C3S and the WMO forecasts, so I think Mr. Gameze can speak more to that in terms of the regional forecasts, but I thought it would be useful to share them in terms of even the very general insight that they might be giving. Where we're seeing that for much of the region, we've got above average, which is forecast above normal temperatures, with some areas in the central having closer to climatology. So when you say climatology, if you recall the map that, or the graph that Mr. Gameze shared earlier, is looking at above normal has got a very clear indicator. We call that climatology. And so in those cases, the farmer also has to prepare for either outcome, perhaps with equal risk, if we're looking at it from a risk assessment perspective. And so based on this, we have some areas which are under climatology, but the majority of the is really looking at, this is the global focus, the above normal. Keep track of the news. You notice, I think every other year they'll say this has been the hottest year on record. And then a year later, again, now we've got another new hottest year on record at a global scale. But we also have those trends also happening in a regional context. And so these above average temperatures are generally in line with climate change observations and predictions. But in addition to the global warming trends, when we have got especially extreme temperatures, these usually coincide with reduced rainfall due to physical processes, which we call the energy balance. So as you're aware, when you have got if you want to, the example I can give of this is that when you sweat, you actually cool down. And part of that is because of the evaporation that occurs. But when it's dry, when you've got reduced rainfall, that's going to mean that there's going to be an even greater demand on the atmosphere, and so that raises the temperature, and we call that the energy balance. So I'm just saying, usually, so what we're seeing when we've got this climatology temperature forecasts, especially in some of those central areas, this might also be an indicator, another indicator towards enhanced forecast rainfall. But of course, as Mr. Gameze mentioned, it is important to consult with your National Meteorological and Hydrological Service, that's your Met agency, for a more detailed national advisory. So that was for NDJ, November, December, January, that I showed. But the same global forecast showing more or less a similar pattern for December to February, as well as January through March. Right. And so the final note on the temperature forecast is that extreme temperatures are generally associated with heat stress for humans, livestock, as well as crops. So for the farmers working out in the field, as well as your laborers, for the livestock as well, whether they are draft livestock or whether it's maybe dairy and so on. So they are all prone when we have got these extreme temperature events. They don't happen throughout, even though we've got a temperature forecast for above average temperatures in some areas. But we tend to have heat waves sometimes, especially during the drier periods. And there's a need to closely monitor your communications and short-term forecasts from your meteorological agencies so that to allow you to take appropriate action. So I also mentioned the issue of that we're not looking just at the SAPOF or the seasonal forecast, but we also have to look at the use of what we call the sub-seasonal forecasts. And then sub-regional forecasts are what I would refer to as the national forecast, but we'll get into that in a minute. So in terms of the sub-regional, sub-seasonal forecasts, we are looking not just at the seasonal forecasts, but we also have forecasts that are produced both up to looking out 2 weeks in advance, which can also allow us to do some tactical decisions in terms of maybe operation for the next 2 weeks, as well as 1 to 3 day forecasts or even 1 to 7 day forecasts, which would allow us to decide, maybe am I going to spray tomorrow, or am I going to, do some fertilizer application and so on. So those forecasts are still important to keep in mind. And then, of course, just mentioning this issue of the regional forecasts, that they should not be used at national level, but more as a guiding tool at regional level. I wanted to share with you that we've talked a lot about the national forecasts, and actually many of our meteorological agencies are already producing these forecasts. They've produced their regional forecasts. So I've just put a few examples here: Namibia, Botswana, Malawi, and Mozambique. But I think most of the meteorological agencies, actually, if you reach out to them, they can share their forecast with you. And you notice that it's actually more granular or in finer detail than what we see with the SAPOF forecast. So the two basically work hand in hand. But for your farming operations, you are better placed focusing or linking up with the national met agencies, getting their forecasts. Some of them even have got WhatsApp groups, and some of you probably are on them already, where they kind of issue these on a regular basis. So that was for OND. We also have forecasts coming from these meteorological agencies for the JFM forecast as well, January, February, March. And then I like this example. I was fortunate to visit Malawi a couple of weeks back. We gave them a training program, but part of that training, we actually got to see the seasonal forecast that they had done, which was very impressive in the sense that, so you've got the national forecast overall, but you also then downscale that to a regional forecast in local language. And so you actually, I think just to emphasize this point, that please see your national meteorological agencies. They will have some of this information at sometimes a very detailed and downscaled level. And you can also, we mentioned the issue of updates. You can also, pester them that, if they are not producing updates, like updated seasonal forecasts, sometimes, when the need is there, that's when the action will be taken. So I think just making sure that they are aware that you are looking forward to these updated forecasts every month and so on. That can also be helpful. But yeah, this is a beautiful product that they have. I think a number of net agencies I'm aware are producing similar forecasts, going out into the districts and meeting the on the ground farmers to share some of this information. And then there's also I think the question was asked on how accurate are the forecasts, and this is something that we're working on together with the SAIDA Climate Services Center. Glad to say, but a few weeks ago, I did do an analysis to show or to try and identify when we forecast above average bias, how often do we get below average rainfall? And so it ranges from 20 to 40%. So this would be looked at as a miss when you get slightly 40% time. Maybe the bias will be in the opposite than what we want, than what we get. But a lot of the times, I think those green and blue colors tend to be quite positive, to say that most of the time when you forecast above average bias, you either get average or above average. And so the same is true for the also holds for the below average forecast. But the point I wanted to raise here, this is a quotation that I found when I was looking through online from an Australian farmer, Andrew Baldock, who says that they actually look closely, at the accuracy of the forecast that they get from the Bureau of Meteorology in Australia. And when this particular farmer was saying that when you forecast of around 70% chance or higher with a 60 to 70% accuracy, then they feel more accurate. They feel more comfortable to actually place some confidence and use this forecast for driving decisions. So it would be very interesting, maybe in offline or later engagements, to engage with farmers on the call or through SACAO, maybe on a longer term basis, to say, under what conditions do you use the forecasts that you get, both the seasonal forecasts and the shorter term forecasts. And this will also help and motivate our forecasters to aim for the accuracy that you require. So I thought I would share also a few slides regarding what the forecast does not cover, what it does and what it doesn't cover. So we mentioned that it covers really 3-month rainfall totals. So I think over a 3-month period, the decile is whether the 33% groups that Mr. Gamedze shared. And so that's what the forecast basically covers. You are totaling the rainfall. And what it doesn't cover, though, is things like, for example, what's the probability of drought? Are we going to have a drought this year or not? The forecast is not going that far, but it's providing some inferences that you can make toward answering some of those questions. Will there be floods or not? The forecast, remember, is looking at 3-month seasonal totals. And sometimes these flash floods or even riverine floods might be a result of 2 to 3 weeks of rainfall, or sometimes even one very intense rainfall, tropical cyclones which occur in a few days, and so on. Within season rainfall distribution, this issue was raised: dry spells, wet spells, and I think Mr. Gamedze, 100% agreement with you there. The issue of research is so important, and we look forward to working with you, trying to address those questions in whatever way we can contribute to your research. And then also the timing of onset or cessation. So it's not covered as well. But interestingly, what we found is that you can also make some inferences based on the forecast. So, for example, one analysis we did a few years ago. It's looking and I realized, sorry, I actually left out the legend there. But those red colors, it's basically showing the correlation between the OND, October to December rainfall anomalies, versus the timing of the onset. So the purple and the dark red colors are showing areas where there is a high correlation between the OND rainfall totals and the delay in or rather the timing of the onset. So basically, when we have in some of these areas here, when we have an above average OND, we tend to have an earlier onset, and likewise, when we have a below average OND, we tend to have a delayed onset. And so, given that our forecast is for normal to above normal rainfall for OND, that also kind of implies an early onset. And I'm sitting in Botswana right now in Gaborone. We've had some consistent rains for the last couple of days. We're wondering whether that's the established onset of rains, and it's actually much earlier than usual. So that kind of seems to be somewhat in line with the forecast, but not conclusive, of course. And then also droughts and extended dry spells are more likely during overall below average rainfall season. So while we cannot conclusively say the forecast is forecasting drought, but these associations, do tend to point in one direction or another, which allows us to support our planning. Right. And also, the forecast, also what it doesn't cover is the issue of the alternative outcomes. We mentioned that when we have a forecast for above normal, it doesn't mean that we don't have below average rainfall. In this, based on the forecast analysis we have done so far, I think this might have been for OND, I think. But in this area and other yellow areas, about half the time is when we got, when we forecast above average, we ended up getting below average rainfall. So the point I want to make is that this needs to be accounted for in a risk assessment. Because of time, I won't go much into this in detail, but there are a number of decision frameworks that you can assist with your decision making under uncertainty, such as the conditions that we have with our seasonal forecast. And these include things like the risk assessment matrix, expected monetary value, and payoff tables. There are also other tools like decision trees, which we won't go into. Those tend to be much more statistical, or rather require a higher level of statistical knowledge, maybe than we have time to go into. I'm sure some of you are already using them, perhaps already, but we'll just look at some of these three in some small detail. And so with the risk assessment matrix, basically what we're saying here is that we're not just looking at the probability of a particular risk, but we also need to look at its impact, right? So on the y-axis here, we've got the likelihood. So this might be maybe our forecast high likelihood of above average rainfall, perhaps. And then on our x-axis, we have also now the impact. So is it low impact, or if it happens, is it going to have a high impact? Or we might even have something also with a low or moderate likelihood. So there's a low chance that it can happen, but if it does happen, it's going to have a moderate or maybe even a high impact. How do we deal with that in our decision making, right? So this is where this risk assessment matrix comes in, and this is just an example of maybe one place where they have low marginal rainfall, low rainfall area, and we have a focus for normal to above normal rainfall. And so if with our high likelihood of above average rainfall, we might have frequent small rains, which will support soil moisture. So this is the high likelihood of happening, but there's a low impact. On the other hand, we've got somewhere where there's a low likelihood of below average rainfall, because the focus for normal to above normal. But if it does happen, then it would have a profound impact. And so we need to look at these aspects when we're doing our decision making. And I'll share one of the items that we can use for that, which is known as the expected monetary value. And so in this case, we are simply multiplying the probability of an event occurring times the value of that event occurring. So this is an example that we would share here, or that I would share here. For example, we've got our focus here for above normal, normal, and below normal. So 40% chances for above average. So this is an above average focus, right? For with 800 millimeters or so of rainfall expected above that, right? And so we might have three different scenarios that we're evaluating. Maybe one is a maize monoculture. Perhaps this year we promised a very high price for our maize. And so it will be, if we do get that, our payoff will be 15,000. Maybe it might be rands, it might be dollars, it might be pula, kwacha, and so on. This might be per hectare, right? On the other hand, if we have a diversified crop, maybe we have a mix of perhaps maize and a more drought-resistant crop, we've got a lower payoff. But if the event that there's a below normal rainfall, we won't suffer as heavy a loss as we would under the monoculture, the first strategy A. And the strategy C is more of risk averse, and we were really focusing on a drought-resistant crop, whereby our above normal rainfall will give us a less payoff, but it will also protect us more in the event that we have below average rainfall in the unlikely chance. So our expected monetary value, we calculate them for the different strategies, And we find that actually in this case, strategy B is the one which has got the best. So because we're multiplying the probability of above average times the payoff for above average plus the probability of average rainfall times the payoff from average rainfall. And so we do this with all these different scenarios. And this is just one tool that we have. There are also other tools that we can look at, including what they call maximum, whereby it's a more pessimistic approach or a more optimistic approach with the maximax. And so these various criteria allow you to incorporate risk tolerance, because we even farming being a business, you are looking at you as the owner of that business, whether you've got a high risk tolerance, or you want to maybe to have a greater version, and so on. And so all of those aspects play into which scenario you finally decide to take. And then just a final note, I think my time is running out here. On the risk assessment, it's not just about threats, but also about opportunities. So we talk about positive and negative risks. And then we also have to look at the cascading or the compound risks, how these cascades from a low rainfall might lead to poor grazing, which might lead to livestock stress, which might lead to reduced head productivity, and so on. And then also we have to understand that there are multiple interacting risks that we have to look at, and then look at your different risk management strategies. Whether it's avoidance, maybe take the action of least regret. Whether it's mitigation, by incorporating operations that reduce the risk of that occurring. Risk transfer, like the insurance, and then simply acceptance. So different risk strategies. You just accept the risk as it is, and you hope for the best. So there are different strategies that can be taken by that. I wanted to share with you quickly also one of the tools that I mentioned. I think I will have this available for the next couple of days. And so just to share that screen there, where I was saying that this tool basically allows you to basically put in the various districts or provinces to allow you to see, for example, how the different, this is for Mozambique, Zambia, that's why I grabbed that screenshot. Or for Tanzania, for example, Mara, this is showing you basically the rainfall for the past 35 years or so. So you can actually use that. And then, so in closing, my final slide here is that focus the probabilistic and the uncertainties. And understanding the most likely outcome is important, but there's a need to prepare for alternative scenarios using risk assessment tools. Multiple focus timescales should be considered for strategic planning through to operational decisions. And of course, I think we've said this 20 times already between Sunshine and myself, we need to consult with the Met agencies. Current conditions need to be considered, not just the focus, but what is currently prevailing, whether you have got high soil moisture, grazing conditions, water reservoir levels, and so on. And then also keeping in mind that there are a multitude of risks that have to be considered together, not just climate risk, but even market conditions. Do we have a high price, low price, volatility, input availability, and so on? So you put all those into a decision matrix and alongside the climate. And finally, to close with saying early preparation is going to reduce vulnerability. So even though our information is uncertain, it is certainly much better than no information at all. And I will close on that one. And thank you for the opportunity to share with your colleagues, and hand back to you, Mr. Doli-san.
Thank you very much, Dr. Tamuka. This is very insightful. Thank you for your time. Thank you for everything. Colleagues, we have heard all these things. I think it's very beneficial for the farmers. I just want to say something before I can allow questions to be asked. Dr. Tamuka has highlighted the importance also of considering both your hydrologist and agrometeorologist in your specific country. It's very important to consider both of them rather than one individual, just hydrology. Because, for example, the issue of drought, the definition of drought from hydrology is different from the definition of drought from agrometeorology. So if maybe the farmers' agricultural practices are heavily dependent upon let's say, the issues of water level in the streams or the dams, the hydrologists in such cases are the ones that are more concerned about the water levels and the issues of in rivers and in dams and so on. And then on the other side, the agro meteorologists are more concerned about the soil moisture deficit or condition in the soil in the field, whether it's raining or not raining. So we must consider both of them for that. And the other, now I would like I can open for questions, but I've got one question first. Dr. Tomaka, you mentioned the issue of high resolution tools, something like even for 10-meter scale. Are those tools, are they freely available for farmers, or are they at a certain cost or something? Yes.
Okay, thanks for that question. So yes, the tool, the 10-meter tool that I referred to actually is it's called Sentinel. It's a satellite image. It's updated I believe every 5 days, and it goes up to 10-meter resolution. Now, the accessibility is regarding your use of it. I think it's not necessarily tailored to farmers' use. But I think by looking at it, finding out more about some of these remote sensing imagery, working with your universities and so on, I think that's maybe a more sustainable way of getting access to some of these and actually trying to get them tailored to your operations. But they are freely available, yes. It's just a question of capacity and skill to handle the data sets and understand what the analysis is saying.
Okay, all right. No, thank you very much, Doc. I can see a hand from Kahisho. Before you can raise your hand, I would also want us to be able to communicate in the chat, ranking us from 0 to 5, 0 being the poorest. If this seminar you find it not to be good, you can say 0, but 5 is maximum. That is, you mean is superlative for excellent. So please, in the chat there, please leave your comments, even on how you think we can improve these webinars. Thank you. For now, I will take a hand from Kahisho. Kahisho, can you?
Yeah, I can hear you. Thank you so much. I've heard very well the conversations, the discussions, the deliberations were so good, and I would say to be forearmed is to be forewarned is to be forearmed. Now we know what we expect from the probabilities. Now we can be able to farm wisely. Thank you so much.
Thank you. Thank you. It was a comment, not a question as such. Do we have any question or any contribution, not questions, as any contribution that you would want to give? Oh, Dr. Prince, please move on.
Okay. Thank you. Mine has to do with the forecasts themselves, especially the ones that are coming from at the regional level. The previous speaker said that they depend on forecasts that are coming from country level Met offices. And then I'm saying, well, how well equipped are the individual country meteorological and hydrological institutions? And following that up, is there a chance, or since we are working with probability, that in fact, what is the margin of error of the forecast that we get from SACOF and also even from our own Met offices?
Okay, noted. This questions, do we still have any other question? I don't see any hands. So, Dr. Tamuga and also Mr. Gamete, you can attempt the questions.
Yeah, thank you very much. I would like to give Sunshine the first go at that one. I think they are more geared towards the forecasting process, which SADC and the member states undertake, I think, over the 1 to 2 weeks before SACOF is released. And I can comment after that if necessary. Mr. Gameze, please go ahead.
May I request Dr. Kuiper to probably, I was trying to capture, but I couldn't capture the entire question. May I request them to probably repeat the questions? Sorry.
Okay, right. So I was saying, I sort of picked up that the regional forecast depends on the country Met offices. And then my question was, how well resourced are these Met offices? How dependable is the information that is coming from them, to the extent that it would translate to a margin of error in the forecast, the regional forecast from SACOF? Yeah.
I think I've got it now. Thank you so much. Yeah, it's a very difficult one, but I understand in terms of its implication. Yes, member states from recent scoping assessments that have been done through different projects and also missions to member states. It is apparent that they are currently struggling in quite a number of areas that may, to a certain extent, compromise the data that is being collected by member states. Yeah. So in terms of the regional forecast, what we rely on mostly is the data, as you have correctly indicated, is that we don't have our own rain gauges, scattered around the region, but we rely on the member states collecting that information. Now, the role that we play as a SADC regional center, at the regional level, what we do, we provide capacity building avenues for both data quality assessment. So we conduct workshops where we capacitate member states on CDMS, which is climate data management systems, how they work and how they can ensure that they maintain the standards and quality of the data, because without the quality control being done properly at the country level, it compromises the quality of the forecast that we issue using this data that we train our models with. So our role is as far as that is concerned, and then we also augment. We support member states with donating automatic weather stations to them through projects. So that also we try to ensure that, because we know that in countries like Angola, countries like DRC, and also Mozambique, they have had wars and they've lost during those time of wars. And specifically for Mozambique, in recent years, they've had challenges with because of tropical cyclones, and also Madagascar and some of the island states. The equipment have been swept away by tropical cyclones. Also in Zimbabwe, we saw that, in Malawi. So in our project, we've built the instrument documentation program, and we bias them towards those countries that have had challenges with those stations. Not meaning that we don't supply the other member states, we do, but we usually have a bias of increased numbers for those member states where we know there are high risk of this equipment being affected or vandalized by tropical cyclone as an example of natural weather systems that affect the very same weather that we want to affect. I mean, we want to measure. They affect the very same stations that are helping us to measure. So we have programs that we're working on to try and see to it that the record that we receive is of high quality, so that the forecast is also of high quality. We also then do utilize satellite observed data like your CHEPS, your ERA5, to assist us with some of the inconsistencies that may be there. But the most important data set that we consider as a region is the one that comes from member states. The other ones are complementary to assist us to check the quality and of course, to a certain extent, try to support where there is a lack of data, because we don't have stations in every part of a country. So the satellite data helps us to augment those spaces where we don't have a record. But otherwise, the data that is important is the one that comes from the national member states. I hope I probably captured the essence of the question. Thank you so much, Chair.
Thank you very much. I don't see another question, and our time has already passed. Just before Mr. Elias gives us a closing remarks, I just want to say only a very short thing. Like, we need to understand as farmer organizations that the weather forecasters, they talk about the likelihood, not that it is going to rain. We must be clear on that. It's about the likelihood. It is likely going to be like this summer. So we need to isolate the two, where they are not saying it is going to be like this. So it is very important for us to know that, to note that, and actually be able to communicate with farmers down there that it's the issue of a chance or a likelihood that there's going to be above average or below average and all that. And one last question again for me is I want to ask a question on which secular, like atmospheric circulation, is very important for each region in Southern Africa. Let's say you are in the interior of the land. Which one, as a farmer, should I be more concerned about? Should I ask, is this year going to be a La Nina, so that I may have somehow an understanding that there's likelihood of above average rainfall? Or maybe if I'm from the islands, which secular is more important for this upcoming season? Or if I'm by the border, close to the oceans like Mozambique, which seculars are more important during the summer seasons? So can you just for different regions to say, okay, this one is more important? A farmer in that region or farmer organizations must be more updated when it comes to this unfolding of atmospheric circulations.
Maybe before Mr. Gamedze comes in, with your permission, Chair, I wanted to just add on to the response from on the previous question, which was regarding. So the way I understood that question is, given the capacity constraints at the member states level, how much confidence can we have in the regional forecast, which is derived primarily from the national forecasts? So I wanted to answer that to add to Mr. Gamedze's response in two ways. First of all, saying that the regional
Hello, I think I lost him. I don't know if all of us have lost him. On my side, he just...
Yeah, it seems, I think it's probably a connection issue.
Okay.
Yeah, let's wait. Maybe he'll come back, because I think his mic is still on, yeah.
All right.
I don't know if he's aware that we can't hear him.
Okay,
he might be speaking, but considering that we are now above time, maybe
maybe
we need to close. Yeah.
Oh, okay.
Okay,
Yes.
if maybe I can respond then, Chair, while we were waiting for Dr. Tamoka. On the question that you have raised, if you remember my slide, I think I gave the different drivers that we monitor as a region. Some of them are relevant for certain parts of the region. As I indicated, like the IoT, it's more influential to the northeastern part of the region, but it affects the systems because the systems are linked. There's no specific system that is going on its own. They are linked. Like your ENSO, which is far away from us in South America, in the Pacific Ocean, it is intertwined with the IoT cycles. Most of the time, when you have got, as an example, when you have got El Nino, so when you've got La Nina, which means ENSO negative. When you've got ENSO negative, which is negative SSTs, and you have got negative SSTs over the IoT region, it results in a drought in areas around Tanzania, northern Mozambique, Zambia, Malawi, northern Malawi. So those are the teleconnections that we know. And if you have got La Nina and you have got positive IoT, it modulates the drought effect. Instead of experiencing a drought, which is what happened in the past few seasons, you have heavy precipitation over those areas around Tanzania. But the signal, as it were, if you're looking at an ENSO as your major driver, you would say you expect that area to be dry when it's La Nina. But if the IoT is in the opposite phase, which means it's in the positive SSTs, means then the signal or the power of La Nina it's moderated by the IoT. Thus, then you have a different outcome as compared to the classic known outcome if you're to use just on. So those are the challenges, and we usually advise users or farmers or whoever the user could be that don't focus for yourself, because you may make a simple mistake and find yourself that you're planning over a situation that if you had used the focus from us or from the member states, it will probably assist you a lot in terms of your strategic planning for your coming season. I submit. I hope it answers your question.
Okay, thank you very much. Mr. Benito, can you please give closing remarks? Then immediately after that, then we can have pictures, group photo. So I will ask after he's done, then we do a group photo. Yeah, thanks.
Thank you, Choti, and thank you, everyone. I'm closing on behalf of Ishmael. He's around, but he requested me to close. So in closing, first of all, I want to thank our two experts, Dr. Mangazile and also Mr. Gameze. I think this is one of the most important interactions that we do have with the experts and the representatives of farmers, as they have highlighted that these are probabilities, and we also need to consult our national meteorological services to check in terms of what is the local situation, what is anticipated or expected in the local situations. But I think these overviews are very important for us to have an idea in terms of what the region focus is all about. So thank you so much, our experts, for this. And we are looking forward for further and more interaction with you. We know that this is a very technical issue, and there are technical concepts that are used. But for us as representatives of farmers, I think we get the information and translate it in a way that can also be relevant and speak to the members that we represent. So thank you so much. I would also like to thank our interpreters for the work that they have done for us to understand each other, especially for our colleagues in Portuguese and French-speaking countries. Thank you so much. And I thank you all that you stayed on. I know that we have gone beyond the time that was allocated for this, but you stayed on with us. We thank you so much, especially our youth. I know the majority is the young agripreneurs. We really appreciate. And I think you are always there when we have these virtual interactions. It's very important, and I think it's good for all of you to understand what is going on in the region and also to assist you in your business as farmers. So thank you so much. We have another interaction on the Wednesday, Shoti, if I'm not mistaken.
Yes.
On Wednesday, maybe you can just briefly say what it is about. Shoti?
Okay, yes. On Wednesday, we are having a meeting on the competencies which farmers organization needs to have in order to run a farmer-led research, whether it's in agroecology or purely in agriculture. What competencies do we need? What competencies we have currently, and what do we really need to have? So that's basically what we are going to discuss. And we have got good speakers like we had today, international speakers. We have got somebody from the US as well, Canada as well, and other maybe West Africa as well. So we have got different people that will be tackling the subject. Please show up for the event. It's going to be very interesting. Thank you very much.
Thank you, Shoti. So we are extending invitations to all of you who are here. I think if the links are not yet sent, they will be sent. But I think it will be another interesting interaction that we have, especially as farm organizations. We are sometimes left out when it comes to research. But now we are going to have an overview in terms of what competences do we need for us to fully and meaningfully participate in the research. So thank you so much, and I wish you the successful week. And we'll meet on Wednesday. As Shoti said, now Dorita will lead us into group photographs. I guess we have to switch on our cameras, Dorita.
Hi,
Yes.
thank you. Yes, let me just give a moment until I can see everything is on. I'm still waiting for a few to come on, please. All right, almost there. There's just a few more coming in, I can see. All right, so I'm going to take 2 photographs, so just bear with me, please. I'm going to do the first one. Please smile. Just give me a sec to save that. Right, so I'm going to the next one, and please smile. There we go. Thank you very much. Thank you.
Thank you.
Thank you very much. Bye. Thank you.
Thank you. Bye.
Thank you, colleagues. Bye-bye.